Hello, I'm Mr. Chowdhury and welcome to our second video in our Advanced Trigonometry series. This video is going to be on the trigonometric ratios. If this is something you're not very confident with, I suggest you go watch our series on trigonometry just to give you a good foundation. This would just be a recap, so we won't go super in depth into it, but just going to help you remember or refresh your memory on the trig ratios. So before we do any of that, we need to make sure that we are confident labeling triangles with regards to an angle. So in the Pythagoras video, we labeled triangles just with regards to sides, but now we're going to label a triangle with regards to an angle. So that changes things a little bit. So the one good thing is one of them does not change. So opposite the right angle is still the hypotenuse. That is still there, still opposite the right angle. The next one is we have an angle that's given to us. So what do you think this side will be called? It's opposite the angle. So what do you think it's being called? I'll give you 30 seconds to have a think. Right, not quite 30 seconds, but you could have paused the video. If you wanted to know what this side is called, it is called the opposite because it is opposite the angle given. So opposite the angle given. Hypotenuse, opposite the right angle. Opposite the angle given, which means the remaining side, the one next to the angle. So here's the angle, this is the side next to it, not the hypotenuse, the other one. That is called the adjacent. So we have our three keywords: hypotenuse, opposite, adjacent. Opposite is opposite the angle given, adjacent is next to the angle given. I suggest whenever you try and answer these types of questions, we want to always go with the hypotenuse first. So we label the hypotenuse first because trigonometry only works with right angle triangles. So if you cannot label a hypotenuse because there is no right angle, we can't use trigonometry. So it's really useful to do the hypotenuse first. So you look for the right angle, opposite the right angle is the hypotenuse. You find the angle that you're given or the one you're looking for, and opposite that would be the opposite, and the one that's left over is the adjacent. So here are some triangles. I'd like you to label them opposite, hypotenuse, adjacent. That's what I need you to do. Opposite, hypotenuse, adjacent. Off you go. Okay, so now that you've had a go at that, let's do the first one together. So there's my right angle. So opposite the right angle is going to be my hypotenuse. So this long side is the hypotenuse. There's my angle. So opposite my angle is going to be the opposite. That means the remaining side is the adjacent. We'll do this one. There's my right angle. Opposite my right angle is going to be my hypotenuse. Here's my angle given. Notice it's changed between these two questions. So here's my angle given. So opposite that angle is going to be my opposite, and the remaining one is going to be the adjacent. I'm just going to tell you the answers for the rest of them. Here they are. Now this one is really interesting because, as we mentioned in the Pythagoras question, we can't just assume right angles. We have to have them denoted. So here, the right angle is not shown. So this is not a right angle triangle. So we cannot label it opposite, hypotenuse, adjacent. We can only do that with right angled triangles. Okay, so now let's have a look at the ratios themselves. Let's have a closer look at the ratios. So here we have a triangle. The angle is 30 degrees. And we can see that the ratio between the hypotenuse and the opposite is a half. Right, if we were to divide them, 0.5 divided by 1 is a half. And the ratio between the adjacent and the hypotenuse is 0.866. If we were to do this number divided by 1, we'd get 0.866. So that's the current ratios that we've got. And I will later on in the video show you where we got these numbers from. But here is a different triangle, slightly bigger. What's happened from this triangle to this triangle? Have a pause of the video, and what do you think's happened? Well, if you said it was increased by a scale factor of 3, that is correct. So what do you think we have to do to these sides? Well, we have to increase them by a scale factor of 3. However, if you notice carefully, the ratios between the sides are still the same. If you were to do this number divided by 3, you'd get 0.5. And if you were to do this number divided by 3, you'd get 0.866. Have a go on your calculator to double check. But that's what would happen. So even though we've increased the size of the triangle, because this angle is the same, the ratios stay the same. The ratio between the sides and the hypotenuse stay the same. So we'll have a look at another one. So here's another one. Same triangle as before. What's happened this time? Pause the video. What do you think? Well, this time we multiply the hypotenuse by 10. So we have to multiply the sides by 10. But once again, if you check the ratios, they are still the same. The ratios are still 0.5 and 0.866. The ratios have not changed, regardless of how big the triangle is. So here we've got a triangle, but this time the angle is given as theta. The angle is given as theta. So we're going to introduce some new terminology here. So we're going to say that this opposite, the ratio of this opposite, we're going to call it sine. Not sin, we're going to call it sine. And that's what this ratio is called. The ratio between the hypotenuse and the opposite is called sine. And the ratio between the hypotenuse and the adjacent is called cosine, or cos for short. Now, just because we've changed the names and the angle, does that mean anything changes? Let's have a look. So here's our triangle. It's just a bit bigger than the other one. What have we done from this hypotenuse to this one? Pause. Have a think. Well, we multiplied it by 5. So what do we have to do to the two sides? We have to multiply them by 5. Right? So the ratios don't change. The ratios will still remain the same because the angle is still the same. Right? So here's under the triangle. We've got sine theta and cos theta. Right? Theta being what denotes an angle. And here it is again. What's changed? What's happened here? Well, we've multiplied by 7. So we have to multiply the sides by 7. Very straightforward. We haven't done anything interesting yet. There we go. We've got sine and cos. And here's our triangle. Now we've changed it to h to represent hypotenuse. Well, I've multiplied 1 by h to get here. Right? I've multiplied 1 by h. So I have to multiply this opposite by h. So I get h times sine theta. And then I have to multiply this adjacent by h as well. So I get h times cos theta. There is one more ratio called tan. And for us to be able to understand that one, we'll have to look at it in a slightly different way. So here is what we're going to look at. So here we have a unit circle. It's a circle on a graph with a radius of 1. And we're going to use this to look at the trig ratios that we've already seen, sine and cosine. But we're also going to learn about this new one called tan. So if you have a look and we move this up, we can see that as the angle changes, the ratio changes. And here's the ratios in action. If you notice, tan is the ratio between the opposite and the adjacent. So what we're doing is we're taking these values and we're dividing them. The opposite and adjacent are being divided to give us our new ratio of tan. Because sometimes we may not be given the hypotenuse, so we need to know all of the ratios. So because we have a ratio between the hypotenuse and the opposite, because we have a ratio between the opposite and the adjacent, we also must have a ratio between the adjacent and the opposite. And that's called tan or tangent. So if you have a look, we move it up to 30 degrees, which is the one we looked at earlier. We can see that it's 0.5, 0.66, and our tan ratio is 0.577. And as this gets bigger, the ratios change. And as you can see, as the opposite gets closer to 1, we can see that happening in real time. And similarly, as the adjacent gets closer to 1, the angle gets smaller. That's what we're looking at. Now, it's really important to try and understand the unit circle. So what I advise you to do is I will link this in the description. And you should go and have a play on this, because we will be looking at the unit circle later on to help us understand some other bits of advanced trigonometry. But the unit circle is a really powerful device to understand where the ratios are coming from. So that first triangle we looked at, which was this one, this is where it's coming from. If we have a hypotenuse of 1 and an angle of 30, the length will be this because of the unit circle. So it's really important that you understand the unit circle, or at least know how it works, to be able to do some advanced trig later on. Okay, just to recap everything we've done, so you have everything in one place. You can copy this down into whatever notes you're making, or you can always come back to this video, into this particular part, so you have everything on one page. We have a useful mnemonic to help you remember the ratios and the sides that they work with. So for example, this one is so, ka, toa. That's the mnemonic. So, ka, toa. So sine works with the opposite and the hypotenuse. Cosine or cos works with the adjacent and the hypotenuse. And tangent or tan works with the opposite and adjacent. So, ka, toa. You also need to remember labeling conventions. So we've got opposite the right angle is the hypotenuse, opposite the angle is the opposite, and the remaining one is the adjacent. Now, you may see the ratios represented in the following ways. So you may see them like this, where it says sine of an angle is equal to the opposite divided by the hypotenuse. We looked at that earlier. Cos of an angle is the adjacent divided by the hypotenuse, and tan of an angle is the opposite divided by the adjacent. Another way that I think you should recognize it is like this, where we're looking at the sides and doing a multiplication. So the opposite is the hypotenuse multiplied by sine of the angle. The adjacent is the hypotenuse multiplied by cos of the angle, and the opposite is the adjacent times tan of the angle. Now you may be asking, so why do we have two with opposite in them? Well, this one uses the opposite and the hypotenuse, and this one uses the adjacent and the hypotenuse. The only things we haven't looked at is what happens if we're not given the hypotenuse. How would we work it out then? Well, we need to know the ratio between these two sides, and that's what tangent is. That's what tangent is the ratio between the opposite and the adjacent. I prefer looking at it like this because I think this form of the ratios is easier to rearrange. However, these are exactly the same. Very little has changed. All we've done here is made the opposite to get from this equation to this equation. All we've done is made opposite the subject. They are exactly the same. So whether you use these ones or these ones, you'll still get the same answer. And lastly, another way that you may want to use, I personally don't like them because they're really easy to misremember, but I will still show you them because it's useful to see multiple different representations and ways to use a formula, is the formula triangles that you may see in science. So once again, it's very similar to so, ka, toa. So we've got sine, opposite, hypotenuse, cosine, adjacent, hypotenuse, tangent, opposite, adjacent. Hopefully that's been helpful. That gives you a quick recap on what the trig ratios are. There will be another video on how to use the trig ratios to find sides and angles, so stay tuned for that one. What I suggest now is you go forth and you do some questions. I suggest Corbett Maths and Dr. Frost as usual. Hope you have a wonderful day. You stay productive, and I'll see you in the next video.